Welcome back to Math 7, Chapter 5, Section 4, Day 2. And today we're going to do something very tricky. We're going to convert repeating decimals into fractions. So there is a little three-step process to do this, and that's what we're going to fill in this rule box. So save about 4 or 5 lines for this, and we're going to go ahead and do one of these problems. First, we're going to change a repeating decimal into a fraction, and then we'll come back and put down the steps because they're kind of tricky if you haven't seen it done. Tricky to understand, okay? So we're going to start with this problem here where we have a repeating number 7, right? It looks like 0.7 or 7/10, but it is repeating, so it's not just 7/10, right? We know that all of the digits after this 7 are 7s, right? So the first thing we do when we have a repeating decimal is we set it equal to a variable. We need to create an equation, and the equation is what we'll solve to get to the fraction, okay? So we have that already in this case. We have n equals 0.7 repeating. And so the next question is, how many digits are repeating? And this is a very simple question. This problem here, there's only one digit that's repeating, and it's 7, right? And so we're going to multiply both sides of the equation by a power of 10 that has the same number of zeros as the repeating block. In this case, the repeating block is 1. So what is a power of 10 with 1 0? It's 10, right? So we can talk about that a little bit more. But we're going to multiply both sides of this equation by 10. Okay, it's kind of hard to write with the stylus. So now we have, let's simplify this. We have 10n on the left side. Okay, on the right side of the equation, when we multiply this by 10, we have increased the place value, right, by 1 place. So we end up with 7 and 7 repeating. Okay, so that makes sense. 7 and 7 repeating. We've increased by this 1 power of 10. So the next step is really interesting. We're going to take the original equation and subtract it in line 3. So we're going to take this equation, the original thing that we had made, and we're going to subtract it from line 2. So let's put a little subtraction symbol here. Okay. On the left side, we're subtracting n. Now, how many n's is that? That's really 1, so let's put that down because sometimes it confuses people if I just write n minus n is 1n, okay? On the right side, though, it is 0.7 repeating, isn't it? So let's just jot that down, 0.7 repeating. And that is the goal of this step. It is to get rid of the repeating block, which is so hard to work with. Okay, on the left side, what is 10n minus 1n? 9n. Good. On the right side, 9n equals, look at this, the repeating block has been canceled. 0.7 repeating minus 0.7 repeating, it's gone, isn't it? And we have just 7. This is excellent. Now we have numbers that we can work with. So in order to isolate n, to find our fraction, you can see we need to undo this multiplication. And so what is the inverse of multiplying by 9? Good, dividing by 9. Excellent. And when we do, we see that due to the multiplicative inverses, we have 1n, n equals 7/9. We have converted a repeating fraction into a repeating decimal into a beautiful fraction. Isn't that awesome? Okay, so let's look at the steps one more time. We set the repeating decimal equal to n. We multiplied both sides of the equation by a power of 10 that has the same number of zeros as the repeating. This has one number repeating, so 1 0. We go ahead and simplify that, and then we subtract the original equation from line 2, leaving us with no repeating block. We then solve for the unknown, and we have our fraction. Okay, so let's back up and write this down in our rule box. Here we go. The steps to changing repeating decimals to fractions. Let the decimal equal n. Second step, multiply both sides by 10 to the n, where n is the number of repeating digits. Good. And then finally we subtract line 1 from line 2 and solve for n. And that is tricky, and that is awesome. So let's try this again. You may need to pause, finish taking this down. We'll try this again, and we'll try it with something a little bit bigger than one repeating number. Okay, let's try changing a repeating number 0.25 repeating into a fraction. This is a little trickier. We've got two numbers repeating. Okay, do you remember the first step? We're going to set this repeating decimal equal to a variable. So since it's a little tight up here, I'm going to do that down here in the next step. N equals 0.25, right? Repeating. Good. Okay, so now we're going to multiply both sides of the equation by 10 to the what number? How many digits are repeating? Good. 10 to the second. And 10 to the second is just simply 100, right? 100. So let's multiply both sides of this equation by 100. Okay, when we do, we end up with 100n. 100n equals, this decimal is going to move two place values, right? 1, 2. Okay, so we end up with 25. And don't forget it was a repeating decimal, so what was after the 5? Another 25, right? 25, and that repeats infinitely, so let's put that repeating line over the top. Excellent. Okay, and now we are going to subtract the original equation. Here it was, the original equation from line 2. Okay, I'm going to show that here. Don't forget that step to subtract. So on the left, we're subtracting how many n's? Good, 1 n. And on the right, we're subtracting that original repeating decimal, 0.25, and repeating. Good. Let's simplify both sides of this equation. We end up, in this case, with 99n. 99n equals, and yay, the repeating block has been wiped out. That's our goal. We end up with just plain old 25. Okay, and to finish, what will we divide both sides of this equation by in order to isolate n? Good job, 99. Divide by 99. And you can see, you can probably write this more easily than I can on this computer, but we've got n equals 25 over 99. 25 99ths. Excellent job. Tricky, but fun, isn't it? Okay, we're going to do one last repeating decimal, and this one is the toughest example there is for today. Anyway, so you can see this one has how many repeating digits? Good, you can see there's 1, right? But this is interesting because there is one repeating digit, but it doesn't start until the hundredths place. So that's something different, isn't it? So what do we do now? You might want to pause the video and give it a try and see what you think. Apply the same steps that we did in the previous two examples, right? Okay, so what are we going to multiply both sides of this equation by? Again, how many numbers are repeating? So the mistake would be to say multiply by 100. That's a mistake. Just because this is in the hundredths place does not mean that we multiply by 100. How many numbers are repeating? You're right, there's just 1. So we're going to multiply both sides of this equation by 10. Okay? So that's the trickiest step here due to that common error of multiplying by 100. So let's simplify. We end up with 10n. Now this is going to feel tricky on this right-hand side too. When we multiplied by 10, we moved the decimal just one place over, didn't we? Interesting. So we end up with 523, right? there's our decimal point, 4. Okay, and let's add what comes after the 4, which is another 4, isn't it? And that would, of course, repeat infinitely. So we doubled the repeating block, so we could see a little bit more of this number. Good. Now we're going to take, remember, the original equation and subtract it from the second line, right? We're subtracting again. Okay, look at what happens when we do. We are subtracting only one n on the left side. Good. On the right side, remember, we're subtracting that entire original number. Look at how it lines up. Remember, when we're subtracting decimals, the decimals have to line up. So we have 52.3 and 4. And that 4 was repeating. Good. So, interesting. You can see that our repeating block is still going to be wiped out by this subtraction, right? And we end up with 4 minus 3, which is 1. Interesting. 3 minus 2, which is 1. Ooh, we're going to have to borrow. 12 minus 5 is 7, and we borrowed, so there's a 4 in the hundreds place, right? Interesting number. That equals our 9n. Okay, tricky. Okay, good. There's no repeating decimal left, so we simply divide both sides to isolate our n. We're dividing, in this case, by 9, aren't we? And so we have our multiplicative inverses. N equals this tricky number, 471.1 and over 9. So what do you recall we do when we have a decimal in our fraction, or we have a fraction in our fraction? Good. We have to blow it up, right? We're going to get that decimal out of there. Let's multiply the top and bottom by 10, right? When we do, we multiply the top by 10, it moves this over one place, and the bottom by 10, and we have 90. This is an interesting fraction. 4,711 over 90. Now, this could be changed to a mixed number, right? How many 90s are in this big number? I wonder, is the top number divisible by 9? Let's see. Remember, we just add the digits. 1 plus 1 is 2, plus 7 is 9, plus 4 is 13. 13 is not a multiple of 9. Doesn't work. Okay, so we could change it to a mixed number, but at this point, we're going to stop here and just understand that we have changed a very challenging repeating decimal into an interesting fraction. Very good. Okay, you're ready to start your assignment, and here you go. There's a little bit of review and then some exciting problems to solve with our repeating decimals. Have fun.